In our previous lesson, we were transposing two-dimensional arrays. They're quite simple when it comes to decision making because there's only two of them. There's no options. We just swap them. And we can simply use this .t notation in order to do that. When we're dealing with arrays of higher dimension, we have some decisions to make, and it's not such a simple operation. So here we have a three-dimensional array, and this is our zero indexed dimension. And this is our first indexed dimension, and this is our second indexed dimension. And if we only want to swap two dimensions, we can use this swap axes method. And we can tell our zero dimension we want it to be in our second index position, and we can tell our second index dimension that we want it to be in our zero indexed dimension. Let's run this and look at our matrix before we do the swap. Here we have two members in our zero indexed dimension. When we run swap axes, we should have four members in our zero indexed dimension. But here we also have four members in our two indexed dimension. But after we run our swap axes, we should only have two members. Now on top of that, we need to recognize that it's not just going to change the shape, it's going to shuffle the values as it does so. So let's run this and we can examine that. So once again, our first index dimension now has four members, and our second index dimension now has only two members. So we've swapped these four members and these two members. And if you examine this, you're going to find that the members of this first dimension have swapped, and the members of this fourth dimension have swapped. However, swap axes is only the next step in complexity, because as swap implies, we are only dealing with two of the axes here. What if we want to swap the members of all the axes, all three of them? Well, then we have to use this full transpose method. Like originally with a two-dimensional array, we can use the .t syntax. If we have a three-dimensional array and we're only dealing with two axes, we can use just swap axes. But if we want to move around more than two axes, we have to go to the full transpose method for that. So let's run this new array, array 6. And we see we've got two members of our first dimension, we have 6 members of our second dimension, and we have 3 members in our third dimension. And recalling that this is index 0, and this is index 1, and this is index 2. So what we're saying here is that we would like to take index 2 and put it in our 0 indexed position. And we would like to take index 0 and put it into our 1 indexed position. And we would like to take index 1 and put it into our second indexed position. So let's run that and see how the shuffle happens. So our first index before, it was 2, but now it's 3, right? Because we moved this to our 0 index. Now this has become 3 members. And our second index, before it was 6, but we moved this second index to our third position. So now we have 6 members in our third position instead of in our second position. Likewise, we have taken the 2 members in our first position here, or the 0 index, and moved them to the second position, or the first index, and we have 2 members here now in our second dimension. This is an advanced topic, and if it seems complex to you, that's normal because it's complex to everyone. And let's just make the point here that when we are dealing with 4-dimension or 5-dimension arrays, it just gets worse.